All right, guys, welcome back to the Causal Inference Seminar. We're very happy to have Alex Wolfowski with us from Duke, presenting on some very interesting work on experimental design. Alex, thanks for joining us.
Thank you for having me. It's good to be doing things in person and not, in my house. So this is some work that we've been doing at Duke in the Polarization Lab, which is a very sort of interdisciplinary group that I co-lead with Chris Bale, who's a sociologist, and Sanjay Hilgas, who's a political scientist. We've been doing this for a few years, and our sort of general goal is to try to understand what drives political polarization, mainly in the United States, though it does seem that some of the stuff that we've been seeing has been reproduced across the world. Our ostensible motivation is to reduce political polarization, to make us be able to interact without hating each other as much. As you'll see, some things work, some things don't work. But
so let me ask a question before I get. Your definition of polarization then has to do with the types of is it about positioning? They're very different and very far away, especially in the policy space, or is something about how those differences express themselves in sort of debates?
By the way, do I need to repeat questions or is this fully mic? All right. So that's a good question, and that's a hard question to answer. So in the stuff that I'll talk about a little bit, there's going to be a little bit of affective polarization, so where you're positioned. There's going to be some issue polarization that we might talk about. Where there, it's sort of where you are in terms of the actual issue attitude. In general, I think one of the interesting things here is that it's a fairly amorphous concept that has lots of different sort of, I don't want to say orthogonal, but lots of different things going on for it, and you are interested in all of them. One of the things that early work concentrated on was trying to, substantially earlier than what we've been doing, is understanding how people interact with each other and whether or not they hate each other. So that is a part of this as well. So there's a lot of ways. I can disagree with you, Carlos, but I am able to have a civil conversation with you. That would be a nice way of that would be a great result for us. All right. But so I do want to say that while I will be talking about our experiments, it motivates a lot of interesting statistical and sort of methodology and sort of big picture empirical questions that, depending on how time goes, I'll be able to talk about some of those. I see. So to scare all of you, this is a talk in 2 acts, so there's going to be way too many slides and way too little time. But the general idea is that the Polarization Lab started from this grand experiment that we ran a few years ago, where we tried to expose people to opposing views, and we were hoping that that exposure would reduce echo chamberness. If we were to show you what other people think, maybe you'll think that those people are not as bad as you currently. The issue there is that we did this on Twitter, and as you might imagine, there's lots of networkiness going on there, and you have to think about that. And we did it in one way, where we essentially were able to eliminate the type of network interactions that we were worried about. But then it motivated the development of statistical design, of actual experimental designs that will hopefully allow us to run these types of experiments without the type of exclusion criteria that we had to introduce. Unfortunately, that intervention led to not the correct direction of results. And so the question became, well, why did this happen? And so we tried a different approach. Rather than trying to expose people to lots of opposing views, we tried to introduce them to one other person who may or may not be from the opposite side and have them talk about a possibly difficult problem. And there we saw better results. This is sort of, it fits with the actual theory that underlies interactions and some of the political science behind this. But that led to different interesting statistical questions. First of all, we generated a ton of text data, And what do you do with text data in a causal inference setting is not obvious. And then how you end up bringing people into these conversations can be felt to be either natural or unnatural. So if I just paid somebody $20 to go find somebody on the street to talk to, that's one type of interaction. If I have people actually engaging with people they're currently engaging with on the internet, that's a different type of interaction. And so trying to understand that is sort of part of our ongoing work that we're trying to build out a research infrastructure to actually facilitate this type of experimentation. So while I'll be talking about specifics, the high level theme here is that experimental design is a hard problem and we should be spending a substantial amount of energy on it up front so that we're not stuck doing analysis on garbage data. All right. I don't know if I need to introduce the potential outcomes to this group, but I will just in case. So this is the Riemannian-Rubin universe of potential outcomes where you have n units who are potentially assigned to one of some treatments. So if there's n units, the vector of treatments is z1 through z1. And the potential outcomes are indexed by that vector of treatments. So essentially, my outcome could potentially depend on the treatments assigned to a bunch of other people, and that could be problematic. The standard assumption up until the early 2000s has essentially been, let's not worry about that. And let's imagine that my treatment can affect me and nobody else. So these are individualistic treatment response type of assumptions. That reduces the space of potential outcomes to 2, yi0 and yi1. And it allows us to define quantities of interest, for example, the average treatment effect, which is the difference between the potential outcomes for each individual averaged over the sample population. And it also makes the design really simple, right? If everybody's independent of everybody else under assumption, by assumption, then I can flip a coin and have some people treated, some people controlled. I only get to observe one of the potential outcomes for each person, but this turns out to be a pretty good estimator for that average treatment. So the issue is that this is a fairly unrealistic scenario for most social processes. And we have to do better. We have to change the type of assumptions that we're working on. So in the first half, I'm going to talk about the actual problem that we tried to solve from the applied perspective, and then I'll give you sort of an introduction to the type of randomization schemes that don't require you to make this strong of an assumption, but that allow this estimator to behave near optimally. And that's going to be really nice. Because the other thing that we as statisticians should be doing is we should be using easy to understand estimators. I don't know how much of this I need to go over, but sometimes there are skeptics in the room. So the general idea is that randomized experiments are a gold standard across the board for understanding causality because you are using them to sort of get rid of any other kind of possible reason why there's a difference between people. So Don Rubin called this a prophylactic effect, guarding against data unbalanced with respect to reported covariance. Now, there's lots of reasons why randomization could be hard to use. And there's lots of reasons why randomization can fail, and there's lots of things people have done about that. But in general, we will be taking the perspective that randomized experiments are actually estimating the quantity that they seek out to be. So this talk is not about causal discovery, and it is not about observational causal inference. We do not have selection. I'm happy to talk about using these data to study other things where there is in fact selection, but and we'll definitely not be doing any of this. The flip side of that is that there's plenty of people who are skeptical about computational social science. And all I can say is that I'm starting sort of my talk from the position that the scales that we're using to study the quantities are validated in the sense that I'm going to think that they mean what they're called. And the effects seem to be consistent across lots of these scales. So whether or not it's, the effect is of order 1 standard deviation or 0.9 standard deviations, it's still in the same direction and it's on all scales that approximately mean the same thing. And the nice thing for us is that people read our paper and they cared, and so they tried to replicate our work, or maybe they tried to do the opposite, but they ended up replicating our work. And so there's lots of studies that are doing some version of this. These are not like straight replications. These people are studying interesting questions of their own, but they're doing things that are in the spirit of what we're interested in, and they end up with similar conclusions. So why study polarization? I probably, again, not super necessary in this room, but essentially we know that Americans are divided on pretty much anything, and it's very clear that partisan identification is the best predictor right now for social policy positions. This is also true for fiscal policy positions. We're going to concentrate on, I'm sure, these questions of social policy, but it's essentially changed from what it was in the 70s and 80s, where age, education, socioeconomic status were substantially more predictive of social policy than partisan identity. And the question is, why is this happening? Is this because people are exclusively targeting themselves with information that they already agree with, and so they just have no exposure to the opposite side? This was the echo chamber hypothesis. And if that's in fact the case, then is social media that is to blame rather than something else? And lastly, if it is social media, how do we study it? Because while we all might think that we have some kind of effect on what happens on our social media, we really don't. There's a big data center somewhere that lots of things happen in that data center, and what we see on our phones or on our computers is exactly what somebody else wants us to see. And the thing is, without being inside of that ecosystem, we can't test it. And so we needed to come up with lots of new ways of thinking about testing the manipulation of social media, where the word manipulation here is not meant to be negative. It's just how do you change the experience of people on social media. So politics is hard, and our idea was that if we were able to just expose people to opposing views just a little bit in some way, then maybe they would see the other side, they would be sort of more willing to understand what the other side was doing, and maybe they would change some socialism. And we pre-registered that lots of things could happen. So in particular, one of our fingers crossed hopes was that everyone would get along. And there's a lot of reasons to believe that this could happen. There's a literature that contact between people can actually help challenge stereotypes. Now, note that's not what we're directly studying. And the thing is that all of this work happened on interpersonal contact, and it's just harder to say no to somebody who is, you see in person and you see them as a human than, a random person on the internet. So it's not necessarily the case that this should. The flip side is that everybody would get along less. There would be sort of stronger identification with their own political beliefs rather than more identification with the central. This is guided by sort of counter arguments literature, where if you try to correct somebody's factual inaccuracy, they do not like that, and they start arguing back, no matter how many points of evidence you bring forward. Now, we're again not going to try to correct anybody's factual inaccuracies. I will put an asterisk on that in the sense that we don't control what they're going to see, because our Twitter bot is going to, do something special. But we do not directly try to counteract any factual inaccuracies. The last one is that there could be differential response among people. And it's particularly driven by the idea that conservatives like tradition, whereas liberals value change. This is coming from very selective contexts on very, very, very small samples. So think of having a focus group and talking to them about a particular subject, and you can see that certain individuals, in this case conservatives, are much less likely to move in any direction, whereas liberals are substantially more likely to move in some direction. But we said, we don't know, it could be one, it could be all, it could be some of these things depending on the context. So we set out to study this. So the first thing that you have to do when you try to organize a study, especially a large-scale one, is to define who the population of interest is. And we were going to do this on Twitter, and so at the very least, we needed people who are Twitter users. We defined Twitter user to be somebody who uses Twitter at least 3 times a week. That may or may not be allowed. I was never an active Twitter user, and I am currently a Twitter lurker. So I see people posting lots, and I see people posting a little bit. Accessing Twitter 3 times a week seems reasonable as being somebody who uses it. We moved away from individuals who identified as independent because we were interested in studying the contrast between Democrats and Republicans, and because we were going to expose people to opposing views without actually knowing what their views are other than their partisan idea. And so there is no opposing view to an independent other than if you start sort of honing in on particular questions. The third one, I think, is the most confusing one. And confusing to me in the sense that I don't know why people are willing to do it. And that might be sort of, this is a place where I frequently ask people, who would give me their Twitter handle for a study for $10? Postdoc or grad student? Staff. Okay, all right. $20, $30. Usually the undergrads break at like $20 to $30. Graduate students will break at like $40 to $50. Faculty almost never break. It feels kind of super personal to give somebody this thing that they'll be able to attach to a survey of opinions, right? Like essentially you're
not even opposed to using my handle.
No, I'm
You're
gonna
gonna use my handle to advertise the survey.
No, I'm gonna use your handle to learn about you.
Okay.
I'm gonna try. Yeah.
But it's not like you have a robot post for me.
No. That's I need to know what you are doing on Twitter to find out what kind of person you are, Carlos. So in essence, we went out, we got a survey firm to give us this type of panel. We got about 1,600 people, and we block randomized them on levels of party account.
What was the price?
Under 100,000, but
No, like per person, what was it?
oh, that's a good question. I think
1,600.
I think we paid. I think that the Twitter handle itself was $10, and I think there were several sequences of surveys, which I think were each $5 to $10. I think we ended up with maybe $50, but don't quote me on that. That's in the supplement. But it was not cheap, first of all. So you need to have access to this kind of money in order to do it. And again, these are paid respondents, and because we're using a survey firm, these are professional survey takers. So there's lots of little asterisks on this, and the thing is, everyone is doing it. That's one of the points I would like to sort of drive home, is that we probably need a different way of doing social science research in order to be able to generalize to at least the American audience. I don't want to dwell on this slide, but this is a demographic slide. And the only thing that's important here that should be in larger text is what are the 2 lines that you're seeing. One of the lines is our sample. The other line is the American Community Survey. So that's a national representation metric. And our thing looks shockingly good, both on racial values and on geography. And this is what happens when you have a non-probability sample. We just sort of have to take it as this is a good sample. There's special sauce behind this that we just don't know what it is. The other issue is that these are, I don't know how many people are in the overall panel for this survey firm, but let's imagine it's 100,000. Yeah, you expect some people to be connected to each other on Twitter, but we found lots of people connected to each other on Twitter before we did the study. And so the question is, what do you do with these people? And what I want to show you is that in these like 2 large, this thing have a thing. In these 2 large components, lots of things could be going on. And I believe the middle person here is a journalist, and they're colored based on what they self-identify as. And one of these people, I don't remember which one, is not somebody whose Twitter handle and page you would be able to show even here. And so we want to, right, these are potentially extremely influential people though, so they could be changing the way things happen. So first of all, how did they end up in what is considered a nationally representative sample? That's something that we should just worry about. But then what do we do with them? And I just want to show you what could happen. So take one of these two large components and think of just influencer behavior happening. So this one person being treated could have an undue effect because this gamma J is how much they're influencing person I's outcome if they're connected and if person J is treated. So our goal is to learn this number 3. We're going to try to do it with the naive difference in means estimator, right? And this different gamma J's are going to induce different biases into this estimate. And the point is, it's such a small network that you would hope that things are not bad. But if all the gamma J's are equal to 1, which is substantially smaller than 3, you get a bias on the order of 1.5%, which is already not great. If you allow that person to have bias that is 2 times the size of that bias goes to 3.4. So they have just a larger influence. If nobody has any interference and only that one person has a bunch of influence, that already starts biasing your estimate. And that's not good. That's something we need to think about. So for our purposes, this is before the methods work was done. And so this was going to cost a lot of money. And so we were like, let's put a pause on sort of the creativity for a second. Let's just try to solve this problem. And so for us, solving this problem was getting rid of sort of the really bad clusters. And then we also split up those dyads in the sense that we kept one from each dyad. But that's not great because now we have this weird inclusion criterion that says you can't be friends with anybody else in our sample. That may or may not be realistic. It's not clear why that was the thing. It was sort of introduced a little bit afterwards. So there's a lot of things that are piling on top of this that are reducing who we can say we're talking about. Our goal was to study the effect of the intervention, which I'll describe in a second, on a person, not necessarily how it might interact over a network. And that was sort of our rationale. But it kind of makes sense to want to know how it interacts across the network, because let's imagine our thing worked out and then Twitter started doing this. We don't know what's going to happen there based on our study. So this is our study. We took, I think we had about 1,600 people. We had 800 conservatives, 800 liberals, self-identified. Half of each group was randomized into a control condition where they just sort of existed. And the treatment condition for each of those groups was the following. You have to follow this bot that's going to be retweeting stuff. We didn't tell them what it's going to be tweeting about, but it was retweeting conservative opinion leaders if the person was a liberal, and liberal opinion leaders if the person was conservative. The definition of what an opinion leader was pulled sort of from a small literature that sort of existed recently on identifying ideology on social networks. And so we essentially pulled the Twitter networks of politicians and journalists and some other groups, and then we categorized them across this ideology scale, and we took the upper end or the upper middle end for one of them and the lower middle end for the other. We check for compliance in 2 ways. One is these people were following.
Question on the treatment. The treatment could be very different over the 2 different groups in the sense that what is an opinion leader for one side can be more extreme or less extreme. But let's say one party is more extreme than the other.
Yes, that.
So
yeah.
how did that come into so intensity of the treatment out to be very different?
I'll get back to it when at the end. That point is extremely well taken, and a reviewer too agrees with it. So this was happening for about a month, right? And so we needed to make sure these people are actually looking at these tweets, otherwise, whatever, right? So first thing is everybody can take a survey of some kind. And one of the things that we did is we retweeted a cute animal picture, and then we removed it before the survey, and we asked them, hey, which animal picture is it? We also asked substantive questions, such as this bot, well, I don't think we called it a bot, but this Twitter account tweeted about blah. What was blah? And we measured compliance level. In essence, it was impressive that people were compliant, because again, they were making that sweet money. So here are the results. At the top, you see intent to treat effects. This is taking our whole sample, and we're measuring the 7-point conservative liberal ideology scale. And so what you're seeing here is shifts in that conservative liberal ideology. Moving away from the center is becoming more like your party, and moving towards it is becoming less like your party. And what we're seeing here is that we made people more like their party. In every instance, if you're worried about p-values, maybe you trust the Democratic results a little bit less, but if you don't worry about the p-values themselves, it does look like there's an effect for both groups, and everybody became more polarized. As you're going down this, you're looking at more and more compliant individuals, so we did an adjustment for compliance. And we also see that Republicans do seem to exhibit a slightly stronger effect. And this is on the standard deviation scale. I don't know that I would vouch for a 0.5 standard deviation change. That seems like a lot. But 0.2 to 0.4 standard deviation change is something that has been observed in the literature and seems to be happening here as well.
Once you learn, the Democrats are out to become more Republican.
They what?
Once you learn, the Democrats are about to become more Republican. It surprised me more.
So there's lots of limitations, as we've been talking about. To Carlos, to your question about what if one of the bots was tweeting crazy stuff, the other one wasn't, or whatever, we did some text analysis in the sense that we tried to evaluate the level of extremeness. We didn't find anything magically strong about it. It is very possible, though, that, for example, for some of our conservative members, they maybe they've never followed a female, and suddenly half of the individuals who the bot is retweeting are female. Maybe that is driving some kind of behavior. We did some of these checks. It's impossible to check everything, and because we were not really powered to understand the mechanism by which this is happening, we don't have anything conclusive. But we checked if it's partisan learning, we checked if it's extremism and demographic differences. It doesn't seem to be.
But did you do any kind of mention text analysis on the what was retweeted in terms of like topics and portion of topics seem like the pages of New York Times or the pages of something more extreme?
Exactly. Yes. Yeah. So that we tried to, but we didn't categorize. Retweeting Fox News at the time was not super extreme, and retweeting the New York Times. This is 2017, so it's not that extreme just yet. But it doesn't seem that that was what was happening. But it's definitely the case that it could have been the mechanism. But it does have important implications, I think, for sort of general social media disruption. That just bombarding people with opposing views doesn't do much. It doesn't do what you think it might do, or maybe you did. So there's plenty of future work on this. I just want to make sure, I want to mention that we did use these data again. So this was a huge labor to collect these data. And it was kind of sad, you're done, you wrote a paper, it's a nice paper, it's in a nice place, we've got a lot of positive feedback from that, but we wanted to use the data more. And I don't have slides for this, but about 6 months after we were done, this Russia troll farms came to be known about. And Twitter released a huge list of the trolls. And because we had the people's Twitter networks, we knew who engaged with the trolls. And we checked, and a bunch of our people engaged with those trolls. And so we were wondering whether or not engaging with the trolls actually did anything in order to change political positions. And the good news, and we should report this in the paper, is that it does not seem like the Russia trolls did much. The thing is, if you were engaging with them, you were probably already there. You were already sort of fairly far in either direction, and so it didn't really matter. Your engagement with them was sort of negligible effect. There, we had to do a selection because obviously we didn't randomize people to interact with troops. And so we have a whole sort of set of sensitivity analyses there where we think that we have identified that the null effect is pretty low. But we hope to do much more with these data.
Using the sort of did their networks change appreciably during the?
Super good question. The short answer is that I don't know exactly. The longer answer is that we've looked at some of these things. It's just what is appreciable change is not immediately obvious. We looked at and we adjusted for the number of followers. We adjusted for this and that. It doesn't seem like there's a lot of that going on, but it's lots to do with this stuff. But the thing is, what do you learn from this? Well, the statistics is that we need new designs in order to accommodate this type of network structure, and that non-probability samples are probably weird. And everybody uses non-probability samples, and so we should be thinking. On the applied side, I think we need new ways of actually recruiting people, because going to these firms, you exhaust these people, right? And you could just keep running it on the same population, but you suddenly have people who have been exposed to versions of your treatment, it seems, which is not good. And you can't just keep excluding them because eventually you'll completely exhaust this. And so what we've proposed and what we're working towards is actually building out a novel research environment in order to do this, and I'm happy to talk about that. But what we'll want to do now is try to actually address this randomization. And I want to do that not super slow, but also not super fast, just so that I can get to our slightly less pessimistic results. So the problems with networks, we've seen what it can do. It can get this undue influence due to somebody's treatment without actually any of the classical problems, such as homophily, where similar people are friends, but they're also similar, so they behave similarly. Interference is what we saw there. And then I'm not going to talk about entanglement, but it's a really neat idea that is an issue when you have observational network data where the treatment is an added edge, and accounting for that is really good. But now we can't do what we did on the first slide. We can't take our potential outcomes and index them just by my treatment, right? Because my treatment might depend, my outcome, sorry, might depend on somebody else's treatment. Under the word interference, you can also write the word contagion. People sometimes use them interchangeably, where somebody's outcome that is measured, the day before might affect my outcome today. We're just going to deal with interference in this context, but there obviously need to be ways of addressing this temporal stuff as well. The other thing that changes is the actual quantity that you want to learn about. And I think that not enough time is spent discussing that issue, because usually you'll collect a bunch of data and then you'll decide, oh, I would like to learn about it more. And turns out that if you wanted to learn about something, but you didn't collect the data to learn about it, you're kind of in a bad place. So for example, total network effect, maximal effect. What happens if you treat everybody versus nobody? We'll talk about that. That is the first thing that people thought about when they started thinking about designs for networks. You might be interested in direct effects. That's what I'll talk about. And that's the value of just treating you as a person and nobody else around you is being treated or not treated. I want to know what the effect of the treatment is on you. That might be important if there's some airborne pathogen that could infect somebody with an interaction or without an interaction, right? Indirect effects are the value of interactions with at least someone. So somebody is being treated and you want to know whether or not there's an effect on the front, the literature on peer effects, or some kind of herd immunity where I don't care how much of the neighborhood is treated, like is it me, is it my friends, I just need to know that there's some kind of, so we'll concentrate on that. But as statisticians and as practical scientists, our control is over lots of things. So the estimand is something that we have to define before the study starts. How we collect the data, the randomization scheme, is also under our control. We get to decide if we're just going to do Bernoulli randomization where we flip a coin, or if we'll do something smart. The last thing that we have is the estimator, how we actually summarize the data and estimate the quantity of interest. My goal is to try to get more people to prefix their estimate. And I don't mean that in the, you should pre-register that you'll use package X in order to study something. But you should think about the estimator as your mechanism for communication. And you can do something very complicated. And then you can take it to the New York Times and they can misinterpret it. And if you would like to avoid that, you should probably choose something that anyone can understand. And so when you're communicating something to people who are maybe not experts in any notion of data science, then saying something about how, you know, this is the difference between the average value for those who were treated directly and those who were not treated directly, that seems like an easy quantity to explain. So that's the one we concentrate. But no, so the estimate is fixed, the estimator is now fixed. So the only thing we get to play with is the randomization scheme. And the idea is that the randomization scheme happens sufficiently in the background that maybe it's not important how we got to decide. And so that can be maybe a little bit more complicated. So early work in this world sort of concentrated on trying to figure out whether or not these quantities are at all identifiable. And this work by Hutchinson Halloran and then Eric Chechin and Tyler Vanderweel thinks about sort of two-stage randomizations where you first separate people into groups. Some can experience interference, some cannot, and then you can do your randomization that way. So you can decompose total effects into direct and indirect. This is really nice if you're dealing with classrooms. It is substantially less useful if you're dealing with Twitter networks, because what is this separation? And so the interesting thing is that the first time I know that the estimate actually drove the definition of the randomization scheme is in this work on total network effects that comes out of Facebook, where they were interested in saying, okay, well, I need to tweak the algorithm by changing something, and I can't obviously, I want to know what happens if I change it to everything. And I definitely, Is there a question? Okay. So I can change it for everybody, but then I don't have a counterfactual, but also like I could lose a lot of money. So what they did in this work called graph cluster randomization is they said, well, I can find microcosms of the network far enough apart. Then I can treat each of those small microcosms as its own network, and if I treat everybody there and nobody in another one, I can actually compare and contrast them. So that the estimate completely drove the actual need for this randomization and the decision for this randomization. We're going to try to do the same, but for the direct. And so our simplifying assumption, that simplifying only in the sense that it makes the math easier, we don't need it, you can expand this to other types of interference, but that the interference happens locally around the direct neighborhood of a node. So immediate connections are what's driving the interference, not multiple nodes. I'll fix a little bit of notation very, very briefly. We have a graph that has two end nodes because I'm going to have to divide by 2 later. A neighborhood is n, d is the degree, and each individual has 3 components to their potential outcome. There's how much they feel the total effect. There's some function that maps the interference. So this is a function from their neighbor's treatment indicator to the real line. And then there's some background covariance. You can think of that as the baseline. And so we will be motivated. So this is model-assisted design in the sense that we will evaluate the behavior of our estimator under this model. And we're going to be motivated by this one. So this is a linear effect. And the average that we're trying to learn about is this average over all of the t. This is our estimate. So this model actually is not that crazy. It maps directly onto the potential outcomes universe. I don't want to dwell on this slide. If you've never seen this paper by Dan Sussman and Ed Roldi, I highly recommend it if you're interested in this network interference universe, because they provide a taxonomy of different assumptions on the potential outcomes that allow us to sort of think about, well, how can I decompose the potential outcomes that are indexed by the whole treatment vector into different components? And the only thing that we're sort of throwing away from here is this last piece, but we could also deal with that. It just makes some of the math worse. So this model fits within this sort of neighborhood interference assumption universe of Sussman and Nairobi, Carmel and Nairobi, some of the other. So our quantities are as follows. The quantity we want to learn about is this average direct effect. The estimator is the naive Riemannian estimator. The ideal estimator, the oracle estimator, is what we would like to have access to. It's the thing that subtracted out the interference function for both sides. And this difference, this C, is what we'll be able to control. So if we control the first moment, it's controlling the bias. If we control the second moment, it's controlling the variance. And here's the whole thing. You have two NP, pair them up however you want. Flip a coin inside each of those points. Under this assumption, which just tells you how much interference one extra treated friend leads to. So this is some kind of Lipschitz smoothness assumption. We can completely control the interference. So first of all, this assumption is standard. People are fitting these models in lots and lots of applied papers. So if you believe in linear interference, so the number of treated friends is what's important, that's gamma D Lipschitz. This is fractional interference, so this is gamma Lipschitz, and so on. And what's cool is that we can characterize the bias under this general sum. And just to sort of point out, the sum here is not over the full graph. It's not just over the partition. It's over the intersection of the graph with the partition. And the partition is in your hands. So pick pairs that are not connected in the graph. Right? I mean, unless it's a complete graph, in which case, you know, good luck in general. You can probably pick almost everybody to not be connected. And so this design is unbiased. So if you're Facebook and your goal is to learn about direct treatment effects and you desperately care about bias and you're not worried about variance because you can just ramp up your sample size to infinity, this will be great. The point here is that this recovers sort of results that we've known about in this area, but this is really good. The story about variance is a little bit harder, and so I would like to introduce sort of what you actually are desiring in this setup.
So let me just clarify that. So big pairs are not connected.
Yep.
Flip a coin. That's it.
That's it.
That's all I need to do.
That's all you need to do in order to get unbiasedness under this general framework.
That's easy.
Yeah. And it's easy, right? So what are you actually trying to do? So imagine this is your network. And your goal is really, in this setting, to try to balance what kind of neighborhood your treated friends have, and what treated people have, and what kind of neighborhood your control people have. So in this example, it's very clear that if you treat nodes 1 and 2, and you leave nodes 3 and 4 in control, then the neighborhoods of all the treated people look exactly like the neighborhoods of the control people. Treated people. Yeah. Neighborhoods look the same. On the other hand, if you did this, which is equally valid in the Bernoulli randomization universe, right? If you flip a coin, that's not good, right? Your neighborhoods are completely flipped. And so the naive estimator is not going to be able to cancel out any of the interference. So we wanted to prove something about variance because we wanted to show maybe some consistency. At the end of the day, we're doing a little bit of statistics here. And so we needed to simplify our world a little bit more. This is symmetric interference. So all of the examples that I had on the first page are in fact symmetric interference examples. People in the applied side of the universe care about this. And what's great is that you can bound the L2 norm of this C by this term. All right. So what does it have? The first part is CP. It's something about this partition. So again, this is for an arbitrary partition. And it has nothing to do with the graph at all. And it's a difference of degrees, so you want to balance degrees, right? The second part is an artifact of being a network problem. It's 1 over root D, which happens in lots of network problems when you're doing stuff with data. So not much we can do with it. The last part is again a summation over the intersection between the graph and the partition. So we can control lots of this stuff. We can use it to build a better partition. So here's the simplest thing you can do. Take your 2n nodes and now order them by degree. This is again before you run the image. Now pair them up. So people in closer degree are paired up. And flip a coin there. Well, this bounds this first term, CP, to be less than or equal to 2 because it's 1 over D max. So you've definitely, this is the minimum that this term can be. So that's great. And under just doing this, you can get, this is the bias term now, it's 1 over D min. This is the L2 norm, so it's 1 over root D min plus 1 over D min. And so in the Dunn-Schnapf limit, you get the mean squared error coefficients. You can do the same thing in the sparse graph limit, just requires a little bit more math. But, in reality, we never actually see the limit, so this is just a good result. You can do even better. So we controlled CP, but what if you have lots of people with the same high degrees, right? So you can actually use that in order to control the last term, because the last term is a sum over the partition and the graph. So if you have 2 people that have the same degree, or sorry, 4 people of the same degree, and 2 of them are connected to each other, just pair up the other way, and so you can control that term as well. And you can show that it actually does surprisingly better. This is a simple optimization. Some results. So the study here is an Erdős-Rényi graph. This is linear interference. CRD strat is a completely randomized design. So half the people are treated, half of them are not. And the strat part here says that our estimator is actually not the mean difference in means, but the stratified by degree difference in means estimate. This is the first order linear estimator for this quantity, so this is the correct thing to do. And as you can see, this does really, really well. Maybe you can't see very well, but this CRD is just unbeatable in this case. Our thing does a little bit better than Bernoulli randomization and naive difference in means. So this is expected. The thing is, if anything else is happening in the world, our restricted design, which is the one that does the optimization at the end, just does better. So this is log mean squared error. This is small world networks. Here are networks that actually don't fit our assumption set. And again, we're doing substantially better on mean squared error. I'm going to skip this without having to go back to it, but we do have results for other estimators, and which require us to choose, other estimators which require us to change the randomizations. So, unfortunately, polarization was exacerbated, and we see sort of these backfire effects, but we were able to develop some cool new designs. So, can we fix it? And the question is, I think, important because you don't want to make things worse and then just sort of walk away. And so we were wondering whether or not, if we just brought people together one-on-one to talk about things, but still in a simulated social media environment, right? It's not that we want you to really feel for this person because you've become close friends with them. We want you to still have the sort of feelings you get on Twitter, but maybe you'll get depolarized. So we built out our first set of apps where we were able to pair people up together to have a conversation. It was very rudimentary in the sense that it was essentially a chat app. There was some voting involved where you could thumbs up some comments, but in general, this was fairly rudimentary. We were interested in studying both affective and ideological polarization. We asked lots and lots of questions in ostensibly unrelated designs where these sort of the app, we didn't want to cue that they need to change their position in the app, so these were separated. And we paired Democrats and Republicans together to have this conversation. Again, this is not including any independents because we were interested in these types of effects. And we needed a placebo condition. We needed a condition that sort of mimics the way people interact with the universe, maybe on social media, but without actually having them have a different conversation. And so what we did is we had people just write a short essay in response to the same prompts that these other people got inside the app. So we had people talk about immigration and gun control, both topics we felt were sufficiently polarized in both directions that maybe we would be able to get some kind of movement from either group. And we balanced the design on a bunch of components. So the important thing that, again, I want to stress here, which is what the actual statistics ends up being about, is that we're interested in the effect of the conversation itself on social media. So the thing we compare to, our counterfactual, is not having a conversation. It's not having a conversation about cats and dogs. So I think that's a very important thing that we've been trying to stress in the actual manuscript. And what do we see? We took lots and lots of different measures of polarization, and we created this average index of depolarization. And so larger numbers here mean more depolarized, which means that on average, people here depolarize. We had lots of different conditions in the app, and I don't want to sort of go through them, mainly because it just starts getting messier and messier. But the setting is that it seems that people are moving, on average, on lots of these measures. And that's a good sign, right? It's a 0.2 standard deviation in this index move. So again, it doesn't seem to be completely unreal. So that's good. But the thing is, we don't know why they did it, right? We just know that they had those who had a conversation seem to have become more depolarized than people who were in the placebo condition. And what's nice about these conversations is that we have the text with them. And so we might ask, are certain conversations better than others, right? Presumably, if you had a conversation with somebody who constantly yells at you, that would be worse than with somebody who's really nice to you. So there's I like being able to say that there's a nascent field. I was able to say that about networks 10 or 12 years ago, and I started working on networks plus causal. And now that I'm thinking about text-less causal, it's a nascent field of text-less causal. And the thing is, much of the work concentrates on, let me get the most powerful NLP model that I can. I will do something with the text on that, and then that gives me real numbers, and I will tell you some causal. And the thing is, it doesn't end up working that great, and it doesn't seem to answer all of the questions we might be interested in answering. And so, again, just as before, where we had lots of control over the quantity of interest or the memorization scheme, here we need to be very careful in defining what is it we're trying to estimate. So, for example, you might say, well, it's not the words in the text, but the sentiment conveyed by the text. Or it's not the words of the text, but it is the manner in which it is written or said, right? There could be lots of things going on, and deciding what those important things are for the applied question is really a matter of expertise. It's not something that I expect a fully unsupervised model to be able to figure out on its own. So in this case, I think it's both intuitive and also supported by the actual theory that politeness and civility are good. If you have a polite conversation with somebody of the opposing view, you kind of feel better about them as a person and maybe even about their position. So this kind of seems supported by our data. So what we have here, these are not causal quantities. It's a plot, so we had people talk about, this is the number of messages they exchanged. And what you're seeing here is two types of people, those that depolarized a lot and those that polarized a little bit. And what we're plotting here is the civility index or politeness index, which is just somebody's dictionary measure for whether or not a text is polite or civil. And it seems suggestive that civility is predictive of depolarization. Right? So if you've been in the causal universe long enough, you know that prediction seems to be not the be-all and the end-all. We need a little bit more. And also, you probably are seeing where this is going. We're going towards studying mediation. Because what we were able to show in the first part of the actual study is that the treatment, having a conversation, has an effect on the outcome, right? But now we're trying to decompose this into the direct effect of the actual conversation, like having a conversation versus the content of it. Now this is where it gets hard, right? It's not that we didn't think that the content of the conversations was going to be important, because we clearly collected it all, so we thought we used it. But it wasn't obvious in the beginning how we would end up using it. And then we were like left in this position where we have text data for half of our people, not for anybody in our control condition. So we can't actually do this in the standard way, because we don't know whether or not the individuals who did not receive treatment kind of sort of feel like the opposing side is civil or polite during conversation. And we need to know that. Unfortunately, this is a very, very common design. I would almost say design defect, because if you have norm-breaking or intense treatments, you don't want to expose unnecessary individuals to things that are kind of like that, because if you don't have to, you should. So how can we do mediation analysis? And in one slide, because mediation analysis is really hard, I will just say that under sufficient assumptions, you can try to impute the mediator. These assumptions are very, very strong. But they might be realistic in this case. And essentially, they're saying that we want to keep the total effect constant as we're imputing the mediator. So it turns out that this can be solved, and what we get to see here is, so this is the total effect. It means that it doesn't move, which is by design, good. And so here we have a decomposition of the direct effect and the indirect. And what we see is that if cross-party conversation moves beliefs about politeness by 0.09 standard deviation, then politeness would be mediated. So essentially, if the treatment is predicted, is causal for these changes in the mediator, then we expect that there's a mediator, which is, and this is a smaller number, 0.9 standard deviation, smaller number than the amount of change in politeness that we see. So it suggests that we could potentially have actually identified some actual mediation. Essentially, right, political polarization is just hard to study. And we have two examples here of what I, would say that are pretty reasonable designs. They're classical designs of experiments in the sense that we did not have anything funky. They're block randomized. We tried to control for everything that's standard. And still, it was hard to identify some of these things. You have to account for the fact that you will have noncompliance. What happens with noncompliance is that you also probably have some attrition going on. So you have and we think that this individual level intervention that we proposed here is promising. So it suggests that if we had a way of inducing maybe polite conversation, or maybe one-on-one conversation that is not starting from a place of hate, that maybe we'd be able to get people closer together on some polarizations. The designs we propose for networks, especially for the direct effect, are provably good. And I think that we will be deploying them in the future when we're actually trying to study this. The problem of that is that bias is only important if you're doing it over and over and over again. Mean squared error is important more often. So thankfully we have control of the mean squared error as well. But they must depend on the actual estimated interest. And as we've seen in sort of the other studies that we're now in the process of deploying, it's very hard to fully understand. I can say it in words what we want to study, but writing down the actual estimate becomes non-trivial, because what is, in this case, what is M of A, right? What is polite with the mediator? What is polite? Is not obvious. The thing I want to start selling is that we're building our own social media research platform, in the sense that Everything that you saw in this talk, it was bootstrapped. It was bootstrapped by Chris. We hired one developer and then a couple of graduate students helped with a lot of the coding, putting together these studies. We contracted out to a firm. All of these things take time, effort, energy, and money. And at the end of the day, graduate student skill is probably better spent on doing the science rather than on building out apps for one-off studies. And so what we've done is we've contracted a large software developer to actually build out our own platform where we'll be able to do lots of these things, including some of these survey things, and a lot of this different design, and simultaneously simulate some kind of notion of social media. So that is our goal. We hope to be in the field within 3 to 6 months, and we hope to either fully open source it or make it definitely available, hopefully after our first set of projects. Thank you.
Any questions on that? So, Alex, couple questions. First, when we're talking about polarization, I mean, I guess it's conventional wisdom that has been wrong, right? But if I look at positioning from either party, over the years, like, are they that different? It doesn't strike me as dramatically different in the hopes and wills that those two parties have if they're in control. So, is it a matter of just rhetoric that we see people being further apart? Is it that people focus on a subset of the issues that are already in the plate of each party from before, the issues that are more perhaps in the extreme of those two parties, and therefore now they concentrate amongst those? Like one party is a party of big government, of social justice, of whatever, and that's like, yeah, it's been the case for a long time. Whereas the other party is a party of business, more less on control, whatever it is, right? So is it, what are we measuring here to define polarization to begin with?
That's a good question about sort of what is the overtime driver of polarization. I don't want to push back too much on whether or not the parties are the same or whether or not they've changed too much, because that is definitely not my area of expertise. I sort of have but I have an understanding of what's going on. And the general gist is that a lot of the things that we're seeing rhetoric about is definitely the more extreme positions. And again, this is something that we're interested in studying. We have not gone through and actually run these experiments, but there is a lot of notions of misperception about what the other party thinks. So one of the reasons to choose immigration and gun control is not just because those are quote unquote hot topics, but because lots of people think that the other side thinks something very different. And so part of the change here could be a little bit of learning that the other side does not think something crazy. But also it is, so I think that's sort of an important thing.
So the reason I asked the question is that what you're trying, your treatment and the hopes that you have here of moderating polarization, right, is on, I don't know if this applies to the demand side of it. Let's call it the demand side of it. Okay. Mm-hmm. Whereas the people who take advantage of it, right, the people that are driving the conversation, the political people, right, they're doing that because necessarily believe in it because it energizes a certain set of people through the rules of having place that get them to vote and get out organized so on and so forth, right? Mm-hmm. So moderating, so your hope is that moderating conversations in the sort of grassroots level will make a change in up, right? So we'll bootstrap change to the full television, like, okay, now we can talk more civilly because that's what the public is demanding.
That's right.
But that's a big stretch there in the sense that it's not like, it's not the independents and particularly the moderates in the country that are driving rhetoric necessarily on political leaders because they are the ones that actually are doing the work that is needed for the parties to move forward. Is that, see my point of like, they're talking to different audiences. These are different audiences.
That's right. we are not trying to change the behavior of politicians with our treatment. Our treatment probably would not work for the AOCs and the Ted Cruz's. We are trying to understand whether or not individuals, sort of that are representative of the American populace, are able to sort of change their position, whether or not it is an attitude towards the other side, which can be a question like, would you be sad if your child married someone from the opposite side? To sort of position issue changes, sort of understanding the other side's issue position as well. So I think that the goal for much of sort of intervention on the general populace is a bottom-up goal. Now, we can get into a separate conversation about, let's imagine that our thing really works and that it, it keeps reproducing. Why would Twitter want to implement something that does this? Or why would Facebook want to implement something that does this? That's a separate conversation that is probably better for drinks. But I do think that I think you nailed it in the sense that it is a bottom-up conversation that we're trying to start.
What do you think the distribution of ideology looks like at the individual level? So I can see sort of two ways this works. One is, on a very crude sort of liberal to conservative scale, it's unimodal, and the sort of median voter is right in the center, and then the other is this sort of bimodal thing. And I'm just wondering, if you had, say, if the true distribution of ideology was bimodal, would these treatments just not separate out the middle even more, or?
Yeah, I don't have a good answer for what would happen under a different universe. The ideology scale that we use, for example, in the first study in order to define the treatments, we looked at the ideology distribution under that thing for our people, and it looked pretty unimodal. I think if you got to a point where the populace was so galvanized that you had bimodality of ideology, I think we would end up it would be harder. And I think we would be having this conversation in a different setting.
That's one of the hypotheses. You're true. That there's a realignment, right, of what's going in each bucket. There's two buckets.
That's right.
Democrat. And there's a bit of realignment happening. That realignment and entrenches that distribution.
That's right.
In a particular way. There was like more cross talk between different groups of people based on, like this sort of like.
That's exactly the
immigration
point.
Group
Yeah.
that then went away, and now it's on the other party, and then
That's right. No, that's exactly sort of the rationale for all of this work, is that party ID now is way more informative of what you believe than your socioeconomic status or your age or your education. So, and that's trying to understand why that is and how do we change that? Because party ID is not, like, as much as you might want, is not in your DNA. And so trying to sort of think about what is it about, like, why is party ID so important, and whether or not that is what we really want for society. That's really cool.
So it's kind of continuing, I guess, with the bureaucrat side of things. So we spent your time talking about how, if I have a network and I have an experimental network, how I can design things better so that I can estimate the direct effect. What about like bureaucrats? What if is there a way to kind of see these treatments propagate through friends? Maybe it makes friends less polarized.
Yeah. So one of the long form goals for me is that every time we launch a study, randomized experiment, we will launch a parallel observational study. That is my hope, and those are hopefully going to have all of these weird things going on. So I will not comment as to whether or not these specific treatments would propagate through these networks, because I don't know. I will say that a design for something like a total effect or a peer effect has to be different. So as I mentioned, right, there's graph cluster randomization for total network. Turns out if you have a little bit more information about the type of network that you have, and you can theorize about where the peer effects are coming from. So imagine that you have community structure in your network, and you believe that within community peers are more influential on you than across community peers. Then you might want to do a slightly different design and graph cluster randomization. So this paper will be posted at the end of this week. There's no other option for it. And this is work that the graduating PhD student had to study sort of a slight variation on these graph cluster randomizations. What you're seeing here is relative bias. And what you're seeing, if there is community structure and community-informed interference. And so our design, so the Oracle design is the black line, which sees like a almost 15% improvement over the naive randomization. The red line is graph cluster randomization, which can improve bias a little bit, but not by that much. And then the yellow line is what happens if you don't have the Oracle and you have to learn the communities. And what's nice is that it's in between the two, so you never do worse in this setting than using graph cluster. And the x-axis, how hard is the problem? So I've been thinking about it. We have another student, great student, who's been thinking about how do you design something specifically for peer effects. And what we're seeing there is that's really, really hard, because the same balancing act that we did in the first paper is not really an option in that second one. We're able to define sort of an optimization problem that's the solution of it is a valid randomization for studying peer effect, but that's a very hard
All right. Thanks, Al.
Thanks, Alex.